What if I told you that your eyes don't actually heal during the day? They repair themselves while you sleep? And there's one simple fruit, inexpensive, easy to find, no prescription needed, that can help support that overnight repair system naturally. No magic, no supplements, just real food, used the right way. If you're over 50 and worried about blurry vision, dry eyes, macular degeneration, or nighttime driving getting harder, stay with me, because this could make a real difference. When you close your eyes at night, something extraordinary begins to happen. Something most people never realize until their vision has already begun to fade. Your eyes don't heal while you're reading, watching television, or sitting in the sunlight. They repair themselves in the dark during sleep when the body shifts into its most powerful state of biological maintenance. Deep inside the retina, millions of specialized cells that were battered all day by light, screens, oxidation, and metabolic stress finally get their chance to recover. Every single day, your photoreceptors, the rods that help you see at night and the cones that give you clarity and color, actually shed damaged outer segments. This is not a disease process. This is normal human biology. But here's the shocking part, that debris must be cleared and rebuilt every single night, or it begins to accumulate, like microscopic trash piling up in the most delicate tissue of your body. Studies in ocular physiology show that this renewal cycle is tightly linked to circadian rhythm, meaning if the body lacks the nutrients or signals it needs during sleep, the cleanup slows down and the retina gradually loses efficiency. That loss doesn't feel dramatic at first. It shows up as needing brighter light to read, struggling with glare from headlights, or taking longer to focus when you walk into a dark room. Most people call this just getting older, but biologically, it is often a failure of repair, not simply aging. During deep sleep, blood flow to the eye becomes more regulated, oxidative stress markers drop, and the retinal pigment epithelium, the layer responsible for recycling visual cells, goes into overdrive, digesting and renewing damaged components so you can see clearly the next day. Without that nightly restoration, research has shown increased vulnerability to macular degeneration, reduced contrast sensitivity, and faster structural decline of the retina. Think of it like this: your vision depends on a maintenance crew that only works the night shift, and if that crew doesn't receive the raw materials it needs, the job is left unfinished. Add to this the reality that, as we age, natural antioxidant defenses decline, mitochondrial efficiency weakens, and the eye becomes one of the most energy-demanding organs struggling with fewer resources. The modern world makes matters worse. Late-night artificial light suppresses melatonin, the very hormone that signals this repair cycle to begin, while nutrient-poor diets fail to replace what the eye used up during the day. So night after night, the damage slightly outweighs the repair, and the change is so gradual that most people never notice until the blur, dryness, and dimness become impossible to ignore. But when you understand that vision is rebuilt in darkness, not daylight, you begin to see why what you do before bed may matter more than what you do all day. Because the final hour before sleep determines whether your eyes enter a state of restoration or silent decline. Inside your eyes is a network of blood vessels so tiny, so fragile, that they are thinner than a human hair. Yet they carry the oxygen and nutrients that keep your vision alive every second of the day. These microscopic vessels feed the retina, the optic nerve, and the macula, structures that cannot store energy, cannot pause their function, and cannot survive even brief shortages in circulation. Unlike muscles or skin, the tissues responsible for sight have almost no margin for error. When blood flow weakens, vision doesn't just get tired, it begins to deteriorate at a cellular level. What many people don't realize is that aging doesn't start with the eye itself. It starts with the breakdown of these delicate vascular highways. Research in ocular aging shows that reduced capillary integrity is one of the earliest measurable changes linked to vision decline long before diseases are diagnosed. The walls of these vessels gradually lose strength, becoming more permeable, more inflamed, and less capable of delivering the steady nourishment the retina demands. And this is where vitamin C becomes not just helpful, but absolutely essential, because vitamin C is a primary building block of collagen, the structural protein that literally holds those vessel walls together. Without adequate vitamin C, the body cannot properly maintain the connective tissue that keeps microcirculation strong, leading to tiny leaks, reduced oxygen delivery, and increased oxidative damage inside the eye. This is not theoretical biology. It is observable in populations with low vitamin C intake, where higher rates of cataracts and retinal damage have been documented. The eye is uniquely vulnerable to oxidation because it is constantly exposed to light, which generates free radicals like sparks flying inside sensitive machinery. Vitamin C acts as a frontline antioxidant in the aqueous humor of the eye, neutralizing those sparks before they damage proteins and lipids that must remain perfectly clear for vision to function. In fact, the concentration of vitamin C in the eye is many times higher than in the bloodstream, a powerful clue that the body prioritizes it there for protection. But here's the problem. Humans cannot manufacture vitamin C on their own. Unlike most animals, we must consume it daily, or our defenses begin to fall within weeks. As we age, absorption becomes less efficient, dietary variety often shrinks, and medications or chronic conditions may further deplete antioxidant reserves. The result is a silent nutritional gap that leaves those already fragile vessels even more vulnerable during the very years they need the most support. Strengthening these vascular channels is not about improving eyesight overnight. It's about preserving the delivery system that keeps retinal cells alive year after year. When circulation is protected, tissues receive more oxygen, waste products are cleared more efficiently during sleep, and the eye maintains the resilience it needs to withstand time. Vision, in many ways, is only as strong as the blood supply behind it, and that supply depends heavily on whether the body receives the nutrients required to maintain it, night after night, repair after repair, long before the first signs of decline ever appear. There is a small, almost invisible layer in the center of your retina called the macula, and it is responsible for the sharp, detailed vision that allows you to read a face, recognize a loved one, or see the world in vivid color. Yet this tiny structure is under constant assault from the very thing that makes sight possible: light itself. Every moment you are awake, photons strike the retina with enough energy to trigger chemical reactions, and while that process creates vision, it also generates oxidative stress, a kind of biological wear and tear that accumulates like scratches on a lens. Scientists have discovered that the macula defends itself using two very specific compounds, lutein and zeaxanthin, nutrients so specialized that the body sends them directly to the eye and concentrates them there more than almost anywhere else. These are not general antioxidants floating randomly through the bloodstream. They embed themselves into the retinal tissue, forming what researchers call the macular pigment, a protective shield that filters harmful blue light before it can damage delicate photoreceptor cells. Without this shield, light penetrates deeper, triggering inflammation and cellular breakdown that over time contributes to the slow erosion of central vision seen in age-related decline. Modern studies using retinal imaging have shown that individuals with higher macular pigment density maintain better visual performance, especially in low light and high glare environments, while those with lower levels experience faster deterioration and reduced contrast sensitivity. In other words, these nutrients function like internal sunglasses, but unlike anything you can wear, they operate at the cellular level, protecting the very machinery that converts light into sight. The tragedy is that the human body cannot produce lutein or zeaxanthin on its own. They must come from diet, and as eating habits change with age, often becoming less varied and more processed, the supply dwindles at the exact time the eyes become more vulnerable. Decades of exposure to sunlight, screens, and environmental stress create cumulative damage, and without enough of these pigments, the macula becomes like an unprotected camera sensor, slowly degrading with every passing year. Clinical nutrition research has linked higher intake of these carotenoids with improved visual processing speed, reduced glare discomfort, and measurable protection against structural retinal changes, suggesting that replenishing them is not merely supportive but essential to maintaining resilience in aging eyes. What makes this even more remarkable is how these compounds work in harmony with the body's nightly repair cycle, stabilizing cell membranes, reducing inflammatory signaling, and allowing the retina to rebuild itself more efficiently during sleep. This means the protection is not passive, it is dynamic, participating in the ongoing renewal that keeps vision functional over a lifetime. When levels are sufficient, the eye is better equipped to handle the relentless exposure to light that defines modern living, but when they are lacking, damage quietly accumulates, unnoticed until clarity begins to fade and recovery becomes far more difficult. The presence or absence of these two molecules can influence how well the eye withstands time itself, acting as guardians of the macula in a world where our visual system is pushed harder and longer than biology ever anticipated. Most people think of sleep as rest, a passive state where the body simply shuts down. But biologically, sleep is one of the most active and critical repair phases the human body ever enters, and your eyes depend on it more than almost any other organ. While you lie in darkness, the brain shifts into a highly orchestrated sequence of hormonal signals, releasing melatonin not just to make you sleepy, but to act as a powerful antioxidant that directly protects retinal cells from oxidative injury. Researchers have found that melatonin receptors exist inside the eye itself, a discovery that changed how scientists understand vision health, proving that sleep hormones are deeply involved in regulating intraocular pressure, retinal metabolism, and the synchronization of the eye's internal clock. When sleep is deep and uninterrupted, the eye experiences a recalibration of fluid balance, allowing nutrients to circulate and metabolic waste products to be cleared away through processes similar to the brain's glymphatic system, a nighttime cleansing mechanism that only functions properly in restorative sleep stages. But when sleep is shallow, delayed, or fragmented, something increasingly common with aging, this cleaning system becomes inefficient, leaving behind molecular debris that contributes to inflammation, dryness, and gradual tissue stress. Clinical studies have linked chronic poor sleep with higher risk of glaucoma progression, reduced tear stability, and measurable thinning of retinal layers, showing that the consequences are not just fatigue, but structural changes to the very architecture of vision. The connection becomes even more striking when researchers observe that people with disrupted circadian rhythms often report worsening night vision, increased sensitivity to glare, and slower visual adaptation, all signs that the retina is not receiving the recovery time it requires. Modern life works against this biology, exposing us to artificial light late into the evening, suppressing melatonin production, and confusing the body into thinking night has not yet begun, delaying the cascade of repair signals that should already be underway. This delay shortens the window during which retinal cells regenerate, meaning that night after night the eyes receive less restoration than they are designed to have. Over years, that deficit accumulates, much like missing maintenance on a complex machine, until function begins to falter. Scientists studying sleep and ocular health have described this as a mismatch between ancient physiology and modern behavior, where the visual system, evolved for predictable cycles of light and dark, is forced into irregular patterns it cannot fully adapt to. Yet when sleep quality improves, measurable benefits follow: better tear production, more stable visual acuity, and improved resilience of photoreceptor cells under stress. This reveals a powerful truth that often goes unnoticed. Protecting vision is not only about what you see during the day, but about how completely your body is allowed to enter darkness at night. Because in that darkness, guided by hormones, circulation changes, and cellular renewal, the eyes are not resting at all. They are rebuilding themselves for the light they must face again. Every time light enters your eyes, it sets off a chain reaction at the microscopic level, a burst of energy that allows you to see but also produces unstable molecules known as free radicals. And these molecules behave like tiny sparks flying through the delicate structures of the retina, capable of damaging cell membranes, proteins, and even DNA if they are not neutralized quickly. This process is called oxidative stress, and scientists now recognize it as one of the primary drivers behind the aging of the eye. The retina consumes more oxygen per gram of tissue than almost any other part of the body, making it extraordinarily vulnerable to this kind of damage, because high oxygen use naturally generates more oxidative byproducts. Over decades, exposure to sunlight, environmental pollutants, blood sugar fluctuations, and even normal metabolism creates a cumulative burden that the eye must constantly fight to control. Research published in Ophthalmologic Science has shown that increased oxidative markers are consistently found in individuals with cataracts, macular degeneration, and other degenerative eye conditions, suggesting that long before symptoms appear, oxidative injury is already reshaping the internal environment of the eye. Unlike a cut on the skin, which you can see and treat, this damage is invisible, silently affecting how efficiently photoreceptors capture light and how clearly signals are transmitted to the brain. The tragedy is that many people assume vision loss is inevitable with age, when in reality, a significant portion of decline is linked to this slow biochemical corrosion. Antioxidants act as the body's defense system, molecules that can safely absorb those sparks before they ignite further damage. But the body's natural production of antioxidant enzymes decreases as we grow older, leaving the retina increasingly dependent on nutrients obtained from food. Without sufficient antioxidant support, lipid-rich photoreceptor membranes, essential for translating light into electrical signals, become especially susceptible to peroxidation, a destructive chain reaction that weakens cell integrity and accelerates degeneration. Scientists have compared this process to the gradual rusting of metal, except it is happening within tissues that must remain perfectly transparent and precisely organized for vision to function. Modern lifestyles intensify the challenge, surrounding us with artificial lighting and digital screens that extend visual activity far beyond what human biology originally evolved to handle, increasing cumulative exposure and leaving less time for recovery. Yet studies also reveal that when antioxidant intake improves, biomarkers of oxidative stress in the eye can decline, suggesting that this is not a one-way path but a dynamic balance between damage and defense. The eye is engaged in a constant battle, absorbing light so you can experience the world while simultaneously working to protect itself from that very exposure. Understanding this battle changes how we think about vision because it reveals that maintaining sight is not simply about correcting focus with lenses, but about supporting the biochemical shield that preserves the health of retinal cells over a lifetime. When that shield is strong, the eye can withstand years of use. When it weakens, deterioration accelerates, often so gradually that it is mistaken for normal aging until clarity, contrast, and confidence in vision begin to slip away. As night approaches, the body prepares to enter one of its most delicate physiological transitions, shifting from activity to repair, from digestion to restoration, from stimulation to cellular renewal. Yet what you choose to eat in the final hours before sleep can either support this transition or silently sabotage it. The digestive system does not simply turn off when you go to bed. Heavy, high-sugar, or highly processed foods force metabolism to remain active, diverting blood flow toward digestion, at the very time when tissues like the eyes depend on steady circulation for recovery. Research in sleep physiology has shown that late-night spikes in blood glucose can suppress melatonin release, delay entry into deep sleep stages, and increase nighttime inflammation, all of which interfere with the precise biological environment required for retinal repair. When glucose rises sharply, the resulting insulin response triggers a cascade of metabolic signals that keep the body in a semi-alert state, preventing the full activation of parasympathetic processes that normally dominate during restorative sleep. For the eyes, this matters profoundly because the retina relies on stable oxygen delivery and controlled metabolic conditions to rebuild photoreceptor components that were worn down during the day. Scientists studying nocturnal metabolism have observed that disrupted nighttime physiology can increase oxidative stress and alter tear film composition, contributing to morning dryness, irritation, and blurred vision that many assume is just fatigue, but may actually reflect incomplete recovery. The type of food consumed before bed also influences how efficiently nutrients are absorbed and utilized, as lighter, fiber-rich options tend to support gradual digestion and stable energy levels, whereas dense meals can create gastrointestinal strain that fragments sleep cycles. Fragmented sleep shortens the duration of slow-wave stages, the period when growth factors are released and cellular maintenance accelerates, including processes essential to maintaining the structural integrity of the eye. Hydration plays an additional role, since water-rich foods help maintain fluid balance without overburdening the kidneys or causing the discomfort that can interrupt rest, allowing the body to remain in a state conducive to repair rather than stress. Modern nutritional science increasingly emphasizes timing as much as content, revealing that the same nutrients can have dramatically different physiological effects depending on when they are consumed. Eating in alignment with circadian biology allows the body to shift smoothly into its nightly restoration program, supporting antioxidant activity, vascular regulation, and cellular renewal that are essential for preserving vision. When this rhythm is respected, the body can dedicate its resources to healing rather than handling metabolic disruption, creating conditions where tissues as sensitive as the retina can recover efficiently from daily exposure to light and environmental strain. Over time, this seemingly small behavioral pattern, choosing foods that are gentle, nourishing, and metabolically calm before sleep, can influence how consistently the eyes receive the uninterrupted repair they require, reinforcing the idea that protecting vision is not only about what we consume, but about when we allow the body to use it, in harmony with the ancient biological clock that governs every cycle of damage and recovery.